Hey everyone, I'm Northern Explorer. Welcome to my channel. In today's video, I'll be making the switch from lead acid to lithium. I ordered my camper in 2020 with the second AGM battery. Lithium batteries have several advantages over lead acid. Lithium batteries can be discharged 100% without causing damage, whereas lead acid batteries should not be discharged more than 50%. Lithium batteries typically last 3,000 to 5,000 charge cycles compared to 500 to 1,000 charge cycles for AGM. Lithium batteries can accept much higher charge currents, which translates to faster charging. The cost of lithium batteries has come down significantly over the last few years, and combined with longer lifespan actually makes lithium more affordable than lead acid. And finally, lithium batteries are 50 to 70% lighter than equivalent lead acid batteries. Each of the original batteries weigh in at 53 pounds and have a capacity of 79 amp hours. This means the original battery bank weighs 106 pounds and has a total capacity of 158 amp hours. However, because of the 50% discharge rule, the actual usable capacity is only about 79 amp hours. When it came time to upgrade the battery on my home power backup system, I went with this 200 amp hour litime battery, and I've been very happy with it, so I decided to stick with this brand. For my camper, I chose a battery that is equipped with low temperature cutoff, self-heating, and Bluetooth. This 165 amp hour battery has over 2 times the usable capacity of the original battery bank. It can maintain 165 amps of continuous discharge current, 165 amps of charge current, and comes with a 5-year warranty. It only weighs 33.5 pounds, which gives me a weight savings of 72.5 pounds. So the first thing I'm going to do is remove all of the retaining brackets for the old battery so I can start from scratch to figure out the proper placement in here with the new smaller battery. Next thing I'm going to do is mount these hatch covers over the vent holes. AGM batteries require venting because they do off gas on occasion. Lithium batteries do not off gas. So the only concern I have with the venting is the heat, trying to get the heat out. So I'll have these covers off most of the time, but in the late fall and possibly if I do a winter camping trip, I'd like to close off the vent holes to prevent the battery from getting too cold, because lithium batteries are sensitive to cold weather. Time to do a test fitting with the new battery. It's good that I have a lot more room in here because I'm still going to need to put in the DC to DC charger. The camper originally came with this Blue Sea battery separator. It works perfectly fine, but it more or less just acts as a trickle charger. And also it's designed for lead acid battery. The charging characteristics of lithium are a little bit different. So I'm upgrading to this 40 amp DC to DC charger. Because the new DC to DC charger is going to allow a lot more current to flow from the truck to the camper battery, I need to upgrade the wiring. So I'm going with this much thicker 4-gauge wire. I'm going to basically follow the exact path that the four-wheel camper dealer went with. So I'm also going to need to upgrade the plug that connects the truck to the camper. I'm going with this trolling motor plug, which can handle a lot of amps. I went with something similar to this when I had my Tacoma and my other four-wheel camper. This is the plug that four-wheel camper installed on my truck, which works perfectly fine, but this one can handle a lot more amps. I'm using these tapped holes as a mounting point for the new high amp DC plug. Well, unfortunately, this is not going to work. It sticks out just a little bit too far. I did some measurements. I might have a millimeter of clearance between the edge here and my camper, but it's just going to be too close. So back to the drawing board on this one. They recommend a 60 amp fuse or circuit breaker be placed in between the truck battery and the charge controller in the camper. And I found a pretty good place to mount one right here on the driver's side of the engine bay. In some of my earlier videos, you'll see me soldering these ring terminals onto the wire. I have since switched to this crimper, which produces a much better connection. There's a brace behind this tie down point because this is an aluminum bed, and I'm trying to thread the wire right in the center of that brace. And if I got my measurements correct, that should be right about here. So I'm just going to drill a pilot hole just to make sure before I go crazy with the step drill. Just going to climb underneath to see where that came out. So there's the brace right there. And that's the hole. All right, plan B will be a much simpler design. So here's the end product. So the way I have this wired, this is the new plug for the DC to DC charger going to the truck battery. And then I left the original four-wheel camper plug here, in which I just disconnected the power, but I left the tag in to the daytime running lights. So the marker lights on the camper will still run, and this is still grounded. So both of these will be in use. All right, So the next thing I'm doing is finding a place to mount the DC to DC charger. It says in the instructions that it can be mounted vertically or horizontally. I actually think it would be better mounted vertically because these cooling fins run this way. But with my very limited space in here, I'm just going to have to run it horizontal, and that way I can see the display a little bit easier where I'm going to put it in here. It also says it should be 2.5 centimeters away from any other surface. So I cut a piece of wood that's pretty close to 2.5 centimeters so I can mount it on the wall as flat as possible. So that's the next thing I'm doing. I chose this DC to DC charger because of its relatively small size, its compatibility with different battery chemistries, its ability to reverse charge the starter battery, and its built-in mppt solar charger. I have a video dedicated to solar charging my camper battery using this charger. So the next thing I'm doing is mounting some bus bars. With the previous battery setup that I had, having 2 batteries, I had 4 places, 2 negatives and 2 positives to plug everything into. But now that I only have 1 battery, that would be way too many things plugged into just the lugs on the battery that I have. So bus bars it is, and then these are 5/16, so I'm going to standardize everything to 5/16, and then everything will fit really good. All right, one of the last things I'm doing is running the wire that connects the DC to DC charger to the plug in the back of the truck. So let's get to that job. When I ordered the wire, it came in a 30-foot length. I thought I was going to have about 5 feet left over. I don't think I have an inch to spare. This barely was long enough. For safety reasons, Litime sends their batteries in what they call sleep mode to wake up the battery. All you're supposed to have to do is connect it to a battery charger. All right, the moment of truth. First thing I'm going to do is turn on the main battery power for the camper, and that's so I can watch the voltage, and that is not showing anything. So either it's too low of a voltage for this to work, or I've already made a catastrophic mistake. We're going to find out here. So now I'm going to turn on the circuit breaker for the charger. And that just turned on, and before anything else happens, I need to change this to lithium, but it's not doing anything. All right, let's try this again. So I just happen to have a litime 20 amp charger, so hopefully I can wake up the battery using this. And if you're wondering why don't I just start my truck and use the DC to DC charger to do it, my camper is not on my truck right now, and I'm kind of anxious to see this thing work. So let's see if I can wake up the battery with this. So I'm going to plug that in and see if we can get this battery to work. And I think part of what my problem was before is I had the battery connected to the bus bar, so it was like connected to everything in the camper. So it's been about 10 minutes. The charger's still going. I just checked the voltage. It's showing right about 13.5 volts. So that means the battery is turned on. I think everything's working good. According to the manual, the battery is shipped with only 30 to 50% of the charge. So now that the battery's turned on, I let it charge up to 75% with the litime 20 amp charger. And now I just turned on the Noki charger that I have here, which is a 10 amp charger. And I'm just making sure that it is actually taking a charge. So I've already set it to lithium, which you can see here. It's on lithium and it is taking a charge. I downloaded the app for the battery so I can see in real time that I'm getting 9.7 amps coming in with my 10 amp charge. 10.2 right there. So that's doing its job, so that's good. So the next thing I need to do is mount the camper on the truck and see if the DC to DC charger works. A couple of notes regarding waking up the battery. The instruction manual has little to no information in regards to waking up the battery. However, Litime has a web page dedicated to this subject. I think my Noco charger could have woken up the battery with a function they call force mode. I didn't read about this until after the fact. My DC to DC charger should also have been able to wake up the battery with a function they call lithium reactivation, but at the time of filming this section, my camper was not on my truck. So the DC to DC charger uses Anderson plugs for all of its connectors, which has worked just fine for the solar connector, for the connector going to the house battery. Where I ran into a little difficulty was the connection from the truck wiring to the DC to DC charger, because I used 4-gauge wire and I think the DC to DC charger uses 8-gauge wire. I'm going to find out as soon as I cut it. So my solution to that was to buy 4-gauge terminal pins for the wire coming in from the truck, which seemed like a good idea, but now that I'm holding it in my hand, it's perfectly obvious that this isn't compatible. There's no way this is going to fit in here. So plan B was to get some 2 bus bars to connect the different sized wiring. So I'm going to put a 5/16 ring terminal on the wires coming in from the truck, which I've already done. And then I need to cut off the Anderson connector for the DC to DC charger and put some ring terminals on there. And then I can connect it with these bus bars. So if you've never taken the wire out of these Anderson connectors before, there's just a little piece of metal, a little clip holding the terminal pin in place, and you just need a really tiny flathead screwdriver to push down on the edge. And then the wire will come out with the terminal pin. So then I just need to replace this for this. Last thing I need to do, put the battery back in, start up the truck, and see if I'm getting a charge. There's one little thing that I'm not doing. There's a little blue wire on here that you're supposed to hook up if you have a smart alternator. I'm not sure if I have a smart alternator, so I'm gonna leave that disconnected right now and just do some testing. And then if I need to connect it, I'll connect it. All right, everything is connected. That is as neat as I could get everything considering the limited space that I was dealing with. Now I just got to go flip the circuit breaker under my hood and start up my truck and see what kind of amperage I'm getting. All right, fire up the app. If you look at that, it was just saying 40. 39.2 amps going in. So just at idle, I'm getting 39.2 amps. I'm really happy with that. About 2 years ago, I installed airbags to help correct a fairly substantial driver's side lean. The airbag on the driver's side needed to be inflated with 40 more PSI than the passenger side in order to level the truck. I'm curious to see if I need less pressure in the driver's side airbag now that I'm carrying less weight on that side. It's like 44 and an eighth and 44 and 3/16. That's pretty close. So on the driver's side, I have 49 PSI, and the passenger side, I have 20 PSI. So 11 PSI less on the driver's side with the lighter lithium batteries. I'm gonna drive around town and put about 10 amps of charge into my camper battery, and then I'm gonna get out and see if the DC to DC charger is warm or hot, and hopefully it's not hot. It doesn't seem to matter if I'm idling or actually driving. I'm getting 40 amps of current going into the camper battery no matter what. So that's a good thing. I can just sit there and idle if I need to charge my battery. So I just put about 10 amps into the battery, and I'm just gonna get out to see if that DC to DC charger is hot. So it's definitely warm. I might space it off of the wall here a little bit, just to give it some breathing room. 130. It's like 134 on top. Yeah, I think I'm just gonna put a few washers behind these screws just to space it out so it can breathe a little bit better. This charger has a safety feature in which it will limit charging current if the circuit board exceeds 140 degrees. It will also stop charging if the temperature reaches 158 degrees. I ended up supergluing 6 washers together to space the charger off the wall by 1/4 of an inch. This has helped lower the temperature by about 10 degrees Fahrenheit. In conclusion, with my meager electrical needs and the ability to charge at such a fast rate, I should never have to worry about running out of power. The upgrade took a few days worth of work, but I think it was well worth the effort. Check the description to this video for the links to the products that I used. That's it for this one. Like and subscribe, and I'll catch you next time.